Hello, ladies and gentlemen, and welcome to Distance Learning. I am your host, Mr. White, and we are here to take a look at making connections with the sine law and cosine law. So nothing new today, just using what we know and applying it. Trigonometry is used in many different areas, including navigation, surveying, construction, and graphic design. To calculate unknown measures, professionals work in these areas first need to decide which trigonomic tools and formula to use. So in other words, these are going to be questions that don't jump right out at you and say, use the sine law or use the cosine law. You're going to have to use a combination of whatever you think is appropriate. Okay, so a triangular garden is designed for a city park. Triangular. I'm looking through, I see nothing about 90 degrees. I see nothing about any special shape. So I'm going to just draw a general, typical, nondescript triangle. It says it's going to have three sides, 12, 14, and 15 meters long. So the longest one should be 15. The next one should be 14, and the shortest one should look like 12. Now obviously these are all not drawn to scale, so I'm going to be using trigonometry to figure out the lengths. If I was to put my 12 meters over here and my 15 meters over here, then things are going to look weird. It's not going to line up. It's not going to make much sense to me. What is the angle of each corner of the garden to the nearest tenth? Nearest tenth means 1 decimal place. So I'm going to need to round to that in my final answers, but only in my final answers. And I want the angle of each corner. So let's give this a name. Let's call it, I don't know. Hey, I saw one of you guys just the other day. Who did I see? I saw Noah. So N for Noah. And how about Jonathan? Where you been these days? We'll make that J for Jonathan. And Connor. So we got NJC. So I'm going to say in triangle. NJC. So I'm going to go after one of these angles first. Now I've got three sides and that's all I have. I don't have an interior angle at all. So that rules out the sine law. I can't use the sine law. Also, it's not a right angle triangle, which rules out SOHCAHTOA. Don't come anywhere near this with SOHCAHTOA. It's also not a right triangle, so you don't come near it with Pythagorean theorem. Those are all no-goes. Let's go through that again. Trigonometry, we're not going to use SOHCAHTOA. Anything with a hypotenuse, stay away from it. There is no Pythagorean theorem being able to be used here, and I cannot use the sine law because I don't know any of the interior angles. So that leaves me with cosine law. So I'm going to go after angle N using the cosine law. So I have lots of room, so I'm going to use it down here. Cosine of N for angle N. Just keeping my work neat so I can follow through it. For angle N, the cosine of N is going to equal the other two sides, remember that. So the side opposite is 14, so it's going to be 15 squared plus 12 squared minus the side opposite it squared, all over 2 times 15 12. And if you haven't memorized that little pattern, if you're working from formulas, then you are not being wise. That is a very difficult thing to do, working from formulas. I suggest that you start doing it my way. So let's take a look here. The first thing I'm going to do is get a numerator up here. So using my calculator, it's making sure I'm in degrees. 15 squared plus 12 squared equals, I've added those two together. I'm going to subtract 14 squared equals, I now have 173 on top. I'm going to divide 173 by 2. Boom, there it is, equals. I'm going to divide it by 15. Boom, there it is, equals. I'm going to divide it by 12. Boom, there it is, equals. So now I have cos n is equal to this decimal ratio. So we do remember that when we want an angle, angle n is going to be equal to the inverse of this decimal. So that decimal is 0.4805555555, etc. So I didn't really need to write this. I could have simply gone second function cosine and give it to me straight. There is the answer. 61.3 degrees is angle n. accurate to 1 decimal place. So there is number 1 done. Now, number 2, let's say I need to go after another one of the angles. So we're going to be working with 61.3 degrees for that one. So now I need one of the other angles. I could do the same thing again. I definitely could, and there'd be nothing wrong with that. Or I can change it up and maybe use the sine law. Let's see here. Let's go after angle C now. For angle C, I'm going to go after this guy. So I'm going to say that sine of C over top of 12, sine of angle C over top of 12 should equal sine of 61.3 over top of 14. Rearranging this, we're going to get sine of C equals 12 times sine of 61.3 degrees all over top of 14. Using your calculators, make sure you're in degrees. So 61.3 sine is that decimal. Times that by 12 is the top. Divide it by 14 equals is this entire thing. Sine of C, I need to do the inverse. Shift sine, and I get an answer of angle C is equal to approximately 48.7 degrees. That's only a 4, so it doesn't round this puppy up. So now I have over here 48.7 degrees. I need the last angle. Well, the easiest way to get the last angle perhaps is to use ASTT, angle sum of a triangle theorem. So angle J is going to be angle J equals 180 degrees because the interior angles of any triangle drawn on a flat surface needs to be, drawn on a let's say flat surface, let's leave it at that, is going to be minus 61.3 degrees minus 48.7 degrees. Using our calculator, 180 subtract 61.3 equals, subtract 48.7 equals, we get a nice round answer of 70. And we want to show that we're accurate to 1 decimal place, so it's 70.0 degrees. There are your 3 angle measurements for the triangle. And life is grand. Now, had you done this in a different order, you'd get your decimals would be rounded a little bit different, and we'd get a little bit different answers. Not to worry, it's all good. There's example 1, all done. Bye-bye.